So we've looked at the relational model and we've looked at algebra. Now the problem, of course, is that we can't actually type those relational algebra operations into the database. So we need a way to do that, and the way for us to actually achieve that is to use a language called SQL. Now SQL is a structured query language. That's where the acronym SQL comes from, and all relational databases implement SQL. It doesn't matter what they are: MySQL, SQL Server, MSQL. Now the nice thing about SQL is that there are various different standards running all the way up to sort of SQL 96. If it's 2 digits, that typically suggests the year the standard was sort of approved and supported. Database applications typically claim to support a particular version, so often they'll talk about, we support up to SQL 96, but then different vendors will add slightly different extensions to the language but the core of the language should remain the same, which is nice because it means that SQL is a transferable skill. Now, one of the nice things about SQL is that, as well as it being a transferable skill, it's quite minimal. There aren't a lot of words in the SQL language. You can do really quite powerful things just with, for example, 3 words: select, from, where. And in fact, today, just focusing on those projection examples, we're just going to use those top 2 words, select and from. So I put blue sort of square brackets around the where expression bit there because we're not going to use that today, but we will use it in the next session. So let's do the same example then, which is produce a list of salaries for all staff showing only the emp number, e-name, job and salary. Now I like to lay the SQL statements out on separate lines like this. So I'll put select on the top line, I'll put from on the second line. Now both the words select and from are reserved words. What that means is those are words which are part of the SQL language, which means we can't use them for our own expressions or our own values. So an SQL statement will always look like this: select from where, but we're only going to use select and from. And the way that you construct it is you put the table name after the from bit. So the relations, the tables go after the from bit. Now you can have multiple tables separated by commas, but in these initial examples we'll just have one simple table. So in this example we would look at those fields. We can see emp number, e-name, job and salary, and we look at the tables and we go, oh yeah, those are in the emp table. So we simply write the emp table in that gap, like that. So the table name goes after the from. On the top line, we write a star, or we write an expression which consists of various column names, various attributes being used in a certain way. So the attributes go at the top. Now the particular ones that we're looking at here are emp number, e-name, job and salary. So to actually show those, all we do is we simply list them separated by a comma, like that. And if we run that, and we can actually run that against the relational database, it will actually show us those particular columns. And if you remember, that's what projection does. Projection gives us particular columns from the table, particular columns from the relation. So how would we do this? Produce a list of department names and locations. So if we wanted to write that down in relational algebra, we write down the name of the relation, department, and that's in brackets. And then outside the brackets, travelling from right to left, you can see the 2 particular attributes, the 2 particular columns, fields we're looking for is dname and location. Now we need to be careful that we use the names from the table. So department names is called dname and location is called loc, and we can see we separate them with a comma. And because we're going to do a projection, that means give me the whole column. That's that pi symbol at the front. So to read that aloud, I would say project dname and loc from the department relation. What would that be in SQL? Well, we're going to use that select from statement. The particular department that we're interested in is department, and then that goes on the second line, and at the top we've got the particular fields we want, the attributes. It's going to be dname and lock. And if we run that against the database, we'd see both of these columns from the department table. Well, what about if you wanted to see all the particular columns in a particular table? So for example, the grade table we know has got 3 columns in it. It's got grade, low cell and high cell. If we wanted to write that down in relational algebra, we'd go project, that's that pi symbol, grade, low cell, high cell, and we put grade in brackets. But in fact, there's a sort of shorthand way. What we're really doing is show us the whole table, show us the whole relation. So the way we would write that down is just to go kind of grade. That's the relational algebra expression for that. How do we do it in SQL? Well, we would go select grade, comma, low cell, comma, high cell from grade. But in fact, the nice thing is that there's a shortcut, which is the little asterisk. And what that does is that says, show me all the columns from the table. And if you were to do that and run that, it would show you this. Now those examples have basically been give me particular columns, but what we can do is we can ask for mathematics to be applied over all the values in a particular column. So for example, what about if we wanted to do a simple percentage calculation? Let's say see what it would look like if we increased everyone's salary by a percentage, something like this. Well, what we would do is we would go sal divided by 100 times 3 plus sal. So what we're saying there is find 3% of salary and add it on to sal. And you can see how we express that inside the projection statement and inside the select statement. So focus on the select statement. We're going show me the names of the people, well that's ename. And then the second column is going to be that 3% of salary plus sal. Now of course here I'm doing sal divided by 100 times 3 plus sal, but you could equally go sal times 1.03 to give you that 3% uplift in their salary. And if you run that, that's the table that will result. Now one of the problems here is that if we just name a column, that will appear in the table. So ename obviously is an attribute that corresponds to a column in the table, so it just produces that. But that second expression, sal times 100, sal divided by 100 times 3 plus sal, obviously that isn't a proper column name. So what databases will do, they will try to make up a column name, and what you get will vary depending upon the database product. Here you can see in Access what it's actually produced is expression 1001. And that's a kind of randomly generated name. If you want to force a name to be used, then we can use this special keyword as. And what we do is we make up a name for the column, and we just put that name after the as keyword. So here you can see sal divided by 100 times 3 plus sal as, and then we make up a name. And here I've called it upgrade sal, it could be increase sal, it could be salary up, whatever word, whatever name you like. It mustn't begin with a number and don't put a space in it, but you can choose whatever name you wish, and then that name will appear at the top of the column. Now, I have mentioned previously that relational databases are based on the relational model, and they do implement mostly the model, but you do get some variations. It is a version and there are slight differences. So here's a straightforward example. If we say produce a list of employee jobs, in other words, project job from emp, what that will do is that will give us the unique jobs. If you remember, because it's relational theory, set theory, there really are no such things as duplicates. So rather than having a list of all the jobs, which would be admin, sales manager, manager, analyst, that whole list of different jobs that all the different people have, what it will do is it will just show us the unique, the distinct jobs. If you type that in, if you translate that into SQL, so it would be something like this, select job from emp, you can see that that does actually give us all the different values for jobs. So the relational model doesn't show us the duplicates. That's because the notion of duplicates doesn't really exist in a relational model. But when the relational model is actually implemented in an actual database product, in a piece of software, there are changes. Here, for example, you would see all the duplicates. If we just wanted to see the unique, the distinct jobs, we would actually have to use the distinct keyword. And what we would do is we would put that in front of the attribute, something like this. And that would give us the unique, the distinct jobs.